Our next speaker, and after this will be a coffee break, is Akmal Chaudhri, a technology evangelist at GridGain. He will present us powering up banks and financial institutions with distributed systems. Akmal is a technology evangelist at GridGain with the role to help build the global Apache Ignite community and raise awareness through presentations and technical writing. He has over 25 years of experience in IT, worked for several blue chip companies such as Reuters and IBM, and also the big data startups like Hortonworks and DataStax. Welcome, Akmal.
Thank you. Okay, thank you. I kind of realize we're running a little bit late, so I'll try and speed up. I don't want to stand between you and your coffee and, have a break. You're probably exhausted by now. You've reached the time of the day where it's after lunch. You're probably fairly sleepy and drowsy and, looking forward to going home. So as the introduction said, I'm an old guy, okay? I've been around a long time. You can see gray hair, white hair, no hair. And very privileged that my colleague Amit, we've known each other 30 years. So we met up in Singapore earlier this year. It's the first time we'd seen each other for ages and ages, and it was fabulous. So, and this is, I think, the third Big Data Week conference that I've done. So about 2 years ago, I was in Malaysia, and MDEC, which is the used to be the multimedia, responsible for a lot of internal sort of projects for the Malaysian government. They organized a fabulous event. It was huge, enormous amounts of interest. And then earlier this year, I was in Jakarta, Indonesia, where they did another one, which was, again, huge, fabulous sort of interest and involvement and lots of things. So happy to chat with you offline about these. Okay, so let's move on. Okay, so we're going to talk about Apache Ignite. So Ignite started life as an in-memory data grid, and you may well be using this technology already, or you may have heard of it. So things like Oracle Coherence, for example. And so in this particular case, I'll kind of drill down and talk about a specific use case, which is always a good thing to do. So rather than just telling you how wonderful the technology is, and just show you some examples of where it's been applied for a real-world application and the kind of challenges that this organization had. So it's actually a large financial institution, Eastern Europe, Russian, and they really scaled this up and stress tested it enormously, and partly as a result of the work that they did, that had feedback into the actual product. So if you're interested in this, just go to ignite.apache.org and you can download this. And although this started life as an in-memory data grid, it's really expanded far beyond that. So you can treat it in a variety of different ways. It can be used as an distributed SQL database, distributed key value store. It will do distributed computations for you, a bit like MapReduce, fork join, these kind of things. And they're extending it with other capabilities as well, such as machine learning, and that's in beta at the moment. So, have a look at that. Okay, so in terms of agenda then, focus a little bit on financial services overview, talk very briefly about Apache Ignite. I kind of touched upon some of the features and capabilities as well. And then in the PDF slides, you'll actually have a little bit more information because we're constrained for time. So I'll focus specifically on the one case study that I wanted to do today, which is Sberbank. And then if there's time, a little bit of Q&A, or grab me outside. Okay, so in terms of financial services then, what are some of the issues that we need to think about? We have to think about this kind of straight-through processing, which historically, same-day reconciliation, no more T+3 method. And if you're involved in the financial world, you'll kind of understand what the issues are here and what the related problems are. We want to be able to speed up this process as much as possible, not having to wait a long time to be able to do this type of thing. Performance is kind of critical. Algorithmic trading as well. Very, very complex algorithms used in a lot of these financial trades. I see some of these job adverts, they're hiring people with kind of physics degrees and PhDs and all sorts of, strange and exotic kind of research areas that they're looking for people with these kind of skills. And it's kind of interesting that, within the financial world, how the application of a lot of these other areas actually can be applied to these real-world problems. Real-time compliance, fraud detection, still a huge problem today. I've been the victim of this myself, several times actually. Several of my credit cards, despite the fact that I'm extremely careful. And my wife tells me I'm kind of paranoid about it to that extent, in terms of keeping pins and these kind of things separate. Nevertheless, it still happens. And it's still a big problem for banks and financial institutions how to deal with this kind of issue. It's a case of trying to do things much faster. Look for these anomalies and patterns and things and be able to detect them quickly so you can stop the problem in its tracks. And in fact, just recently, last week I was in Paris. One kind of mistake I made was that I'd received a new credit card, and it kind of ended, one ended at the end of September, the next one started at the beginning of October, and I forgot to change it. So I tried to use the old card, and the bank obviously realized there's a problem there, they put a stop to it. And this had a kind of a knock-on effect, but unfortunately my taxi didn't get paid for and all sorts of other issues, and so they did a pretty good job in terms of realizing that there's a problem. This shouldn't be used, it should be the new card that should be used with the new expiry date. And I spoke to them on the phone. We were able to clear it up pretty quickly, but that's the kind of response that you want. You want things done very, very quickly to stop these kind of problems. Now, in my case, it was an innocent mistake, but the thing is, these things happen, and they happen quite frequently, and banks are suffering huge losses still today as a result of fraud and other issues. Okay, and retail banking. So we all have one of these now, and we all want to do our banking online. I'm actually a bit of a Luddite. I was late to this. My wife was much, much faster at getting this kind of mobile banking, getting the apps, being able to use it. I've kind of recently joined her in being able to do this kind of thing, and it's really, really useful in many cases, of course, that we have the ability to transfer funds, be able to pay people, and do it without having to go to a laptop. You type in all sorts of pins and security codes and these kind of things. So there is a level of protection obviously on here, but our entire lives tend to be on here as well. I mean, this is the, I guess, the downside. Risk management, kind of associated with the some of the previous issues that we've talked about. Okay, so in terms of the requirements then, time is money, okay? So performance is very, very important. And this is not just in the financial world, of course, in many, many other domains as well. So the world has kind of changed. It's rapid movement, business opportunities, threats. We need to be able to respond to these issues much, much faster. In a lot of industries, deregulation as well. I mean, look at the case of British Telecom. Once upon a time, almost a monopoly. And subsequently, lots and lots of competition, lots of organizations offering new capabilities, new services. And so it's very, very important to be able to adapt to this changing climate and changing environment as business needs move. Huge amounts of transactions, obviously, trillions of dollars get traded all the time, money gets moved around, shifted around the world, and so throughput and latency, these are very, very important. I think particularly for financial institutions, performance is critical. Again, tying back to the first bullet point that was there. Acid consistency, you may have heard of the atomicity, consistency, isolation, durability, traditional kind of database management systems, of which relational is still the dominant technology. Some of you might be working with other sort of modern technologies such as NoSQL databases that tend to work a little bit differently. So the atomic kind of guarantees aren't quite the same. They may do it at the level of a document, for example. But generally, a lot of these systems, because they are designed for distributed processing, it tends to be eventual consistency, which is different. So there you're kind of looking for guarantees. You might say, okay, I'm willing to take a 5-millisecond or a 10-millisecond hit, but the view of my data may not be consistent across my entire system, but that's okay. That might be acceptable to you. But I think in a lot of financial applications, ACID compliance and the fact that we need to move from one consistent state to another consistent state is very, very important. And either something gets done in its entirety or it doesn't get it done at all. Very important. Durability, of course, data loss. We don't want that. We want the ability to have some confidence that our data is being stored if things go wrong, and especially in cluster computing as well, that things can be recovered very, very quickly. And with the financial institution that we'll look at, one of the SLAs that they have is that it's 5 minutes to recovery time. So if there's some catastrophic problem that they have, they need to be able to recover their system very, very fast. Familiar APIs. So SQL, perhaps many of you have worked with SQL, relational technology. You may like it, you may hate it. The point is that it's the lingua franca. It's intergalactic data speak. Pretty much everyone uses it. And even if you're a NoSQL vendor, despite their argument that you don't need it a few years ago, today if you look at them, they're all adding that capability back in again, because the fact is that lots of BI tools use it. There is a huge skill set out there of people who understand and know how to apply it, and then using things like data manipulation, data definition, these kind of schema and sort of query statements, and being able to create tables and indexes. All of this is reasonably well known. Now, there is an issue around SQL in terms of its size. I mean, it's a huge language. So originally, the specification was kind of like this. I mean, today, it's well over 1,000, 1,500, 2,000 pages large. I think no single relational vendor implements all of it. I mean, that's just a fact of life. It's too big. They tend to pick the bits that they kind of agree with and feel that their customers are going to use. But there are some standards out there. So things like ANSI SQL 99, for example, is very well supported, widely used, and that is pretty good across the range of products that you might be using, whether they are commercial products such as Oracle, DB2, Microsoft SQL Server, or things like MySQL or Postgres if you're into the open source space. So that's an important thing, an important consideration. So the other thing is that in terms of relational systems, yes, still very much the dominant technology. And by the way, one of the kind of numbers that often gets quoted by the NoSQL vendors particularly is that they're making huge inroads and they're knocking Oracle off its pedestal. If you're old enough like me, you'll kind of remember the arguments during the late 1980s, early 90s. What was the big thing in those days? It was object-oriented databases. That was the big thing. It's going to take over the world. It's the end of relational. Never happened. Right? 10 years later, it was XML databases. It's going to take over the world. End of relational. Never happened. Okay? Today, of course, it's NoSQL. It's going to take over the world. It's the end of relational. It will not happen. Okay? I guarantee it. Okay? So the same kind of arguments, the same kind of mistakes that vendors tend to make, you can understand from their perspective, of course, because they've got something new and hot to offer. And despite the fact that traditional relational technology only accounts for about 10% of all data stored in the world, and therefore there's a huge potential in terms of where you can target new products and services, unfortunately they tend to go after the big guys, and that's kind of, I think, the wrong thing to do. It's still very much an SQL-centric world, and SQL tends to be part of our architectures. So this whole idea of kind of scale up and scale out, yes, there are some limitations to relational, and of course, if you are paying license fees to the big vendors, you are probably paying a lot of money to them. There are choices, Postgres, MySQL, for example. But generally, with relational, you can take your initiatives internally to be able to distribute data in a way that can work reasonably well. So things like vertical partitioning, horizontal partitioning, these things can kind of work, sharding. You can do it yourself. There are companies out there that will have gone through this process and they've done it. But the thing is, it's kind of an expensive process. The skills required and the ability to manage all of this yourself, whereas a lot of the solutions that we tend to look for tend to be off the shelf today. I think it's much more important that we try to find reasonable solutions where we can without having to put too much effort in ourselves. Years ago, when I first started my IT career, I worked for Reuters, and Reuters tend to develop a lot of their internal protocols, for example. I mean, that's the kind of thing you wouldn't do today because industry standards are available. You can just take these solutions and apply them directly without having to reinvent the wheel and do things yourselves. So relational, great in terms of scale up. I mean, you just buy a bigger box, you can scale the system up as much as you want. Whereas traditionally, with cluster computing, with the likes of Spark, for example, and Hadoop, and even many of these NoSQL products, what we're trying to do is kind of scale out. Just add additional nodes as you need them. You improve the processing power of the cluster. You can do more. And if you find you don't need the resources, just take those nodes down. I mean, this elastic kind of scalability, very useful feature that you get. And again, if you look at the likes of Big Step and these kind of cloud providers, Amazon, if you've used them, very similar sorts of capabilities that you get there. Pay for what, just pay for what you need and pay for what you use. Cannot support growing load, okay, so just relational on its own is not going to really help us. It's great for many types of problems, but there are new things that we need to think about. So, what's the new architecture? What are we kind of trying to suggest is the way forward? So, in memory, keep things in memory tends to be really, really fast. You're just running things at memory speeds, okay? You don't have to read things off disk. So this is the kind of principle behind in-memory data grids, that we are able to keep things in a cache. It's distributed across a large cluster, and then we can run these queries really super fast. Horizontally scalable, again, the idea is just add additional resources, create new nodes as you need them. The cluster will rebalance itself. It will give you the whatever additional resources that you added. You can then use those for processing, for distribution, parallelized operations, these kind of things. Okay, very, very useful. Always available. Okay, so it's important in this type of cluster computing environment that as things go down, it's a self-healing system. It can take care of itself, and you're guaranteed, if you're kind of partitioning your data, you've distributed in a suitable fashion, that parts of your cluster might go down. That's okay. It's not a problem. If you look at Google, for example, they use a lot of commodity hardware, and they've got huge data centers, and invariably, large parts of their system actually go down on a regular basis. But it's just that they are very, very large that we don't notice that, okay? Because they're able to then replace those systems fairly quickly, and because the data are distributed anyway, it really doesn't make a big difference as far as we, the end user, see it. Durability, okay, so one of the things that Ignite, for example, offers now is that although it's historically come from this kind of in-memory data grid background, it gives you the ability to write things to disk if you need it. So it offers persistence natively, okay, it's part of the one of the components that comes with Ignite today, or if you are using a relational system or HDFS or a NoSQL system, it can directly plug into that as well. So the idea is no rip and replace. It's a complementary technology. It will do the things that you need it to do. You keep your existing investment in the systems that you have already. There's no need to take those out, and that's a kind of important business consideration, which I think we always tend to overlook. ACID, we talked about this a few moments ago, the importance of this, I think particularly for a lot of financial applications, and we talked about SQL, DDL, and DML as well, very important. Co-located processing. So one of the things that we can do in this type of cluster computing, and which Ignite particularly is good at, is this ability to have data located with other data, so that if we know that there are certain usage patterns or certain queries that we're going to run on a regular basis, rather than having to hit our entire cluster and be able to bring it to its needs, which you could do, if you're doing some kind of distributed SQL join across the entire cluster, there are ways that you can mitigate these kind of risks and issues in terms of careful design. So think about something like a company and the employees that work for that company. We can co-locate that data on a particular node. Now, because of the way that Ignite works, it's a distributed hash map. It knows where the key values, in terms of the algorithm that it applies, where the data are stored, so it knows exactly where to go. And if we know that there is a company stored on a particular node, we know the employees associated with that are also there. That gives us the ability to bring the processing to the data. We don't shift the data around, because that can be an expensive operation in our cluster. Okay, so Ignite could be one solution, and again, as kind of following on from the previous speaker, it's not necessarily the only solution out there. Okay, you've got choice and you've got alternatives, but I think it's a nice one in terms of the fact that it's open source, it's very comprehensive, very agile, very flexible, gives you a lot of capabilities, a lot of components, and you can use as much or as little of it as you want. Okay, there's no hard and fast rule that says that you have to use all of the capabilities. Again, it's this idea of no rip and replace. Okay, if you've got significant investment already in some existing systems, use those systems to the best of their ability, and then complement that with Ignite, its scale and performance, cluster computing, processing, the distributed SQL, for example, and there's a whole range of other things that are in the pipeline as well. So machine learning, I kind of touched upon a little bit earlier. That's still in beta. It's coming along. But again, that could be very, very useful. And streaming, if you're Flink or Spark streaming user, again, Ignite can act as a kind of a sink. be able to read that data in. You define an event window. It could be the last couple of events or the last 5 minutes worth of data or whatever. I mean, that's very useful to do as well. Okay, and at a high level, this kind of 50,000 foot view or 30,000 foot view, however you want to say it, this is what the big picture kind of looks like. So we've got the memory-centric storage, okay, durable memory, Ignite native persistence in the bottom left there, that it offers a whole range of capabilities. If you want to be able to persist your data, have it survive beyond the process that created it. And you can plug in with third-party tools as well. Okay, so again, the importance here is to keep your investment in what you already have. No need to throw those systems away. So you may have significant investment in Oracle or DB2 or SQL Server, or you may be working with open source like Postgres, MySQL, these kind of things. That's fine. All of these will work. At a slightly higher level, then we've got a range of these components. SQL we talked about. It's a key value store. Okay, can do transactions. All right, so the kind of things that you expect from a good database management system. And these can be both pessimistic, okay, so you're taking locks, or they can be optimistic as well. So you're using the system in the way that you are confident that there won't be significant conflict, which might apply in some cases. Services, streaming, machine learning we talked about, and then of course lots of verticals. Now, on the right-hand side in the blue, these are the kind of commercial enterprise-level services for which you'd need to pay, all right? So this is just to be honest with you and upfront with you. Few things are not available. It's the standard kind of open source model, okay? So give your software away for free, which GridGain did to Apache, and the vast majority of it is probably going to be okay for you. But if you need a little bit of enterprise support, things like snapshots, for example, that could be very useful. Monitoring and management, security, and some strong sort of security features, then you essentially have to come to GridGain and you pay for those capabilities. But beyond that, if you look at what Ignite actually offers, for the vast majority of cases, people are actually pretty happy with the open source offering. Okay, so let's quickly talk about the case study. I appreciate I'm kind of running out of time. So there's a couple of slides associated with this, all right? So this, and in the PDF, there's a few other examples. So there's ING, for example, is another financial case study. So this is a big bank, okay? It's a huge number of branches, thousands and thousands of branches across all 83 constituent entities of the Russian Federation. 11 time zones, okay, that's how much they span. And you know how large Russia is, right from almost the Atlantic right to the Pacific, so huge. And then serving 70% of the Russian population. So they are a very well-known bank and used by a lot of people there. So the key problem here is increased transaction load due to online and mobile. So people are moving to this all over the world, okay? Not just in the West, but if you look, Southeast Asia, for example, Asia, in India, for example, pretty much everyone, the first thing everyone gets is a mobile phone. And if you look at Kenya and some other countries in Africa where they do mobile banking now as a way to guarantee that people actually receive their money, because it's very difficult for people to get to physical sort of banks to be able to carry out certain types of transactions. What they found that unfortunately they're paying through the nose for a lot of licensing fees and huge cost in terms of total cost of ownership regarding their existing sort of in quotes legacy systems. So they want to move away to a new architecture where they're trying to use open source technologies as much as possible to help them reduce some of those costs, but equally re-architect their system in a way to give them the ability to see far more about what the customer is doing. It's this kind of 360-degree view of the customer. What are the products and services that they may be interested in targeting to the customer based upon what existing services and, for example, how many bank accounts do they have? What types of bank accounts do they have? Do they have a mortgage? Do they have other loans? Looking at the big picture, if you like, and being able to respond aggressively again to these needs. So what GridGain did was work with this bank, and it says here delivered 1 billion transactions per second on 10 nodes. Okay, and these nodes, I think each of them have a couple of terabytes of memory. So they're trying to cache as much of the data as they can in this kind of distributed cache, distributed data grid, and be able to run a lot of operations in memory, which gives tremendous performance boost. state-of-the-art new core banking system. So again, they're starting from a position where effectively it's a clean slate, and then they're saying, okay, how do we build this up from the ground level to be able to address some of these requirements? And on the right-hand side here, you can see how, again, this kind of high-level picture of what it is, their architecture. There's the cluster, the memory-centric storage that we talked about, and then using some of those capabilities that we talked about as well, things like SQL, for example, the compute engine, for example, MapReduce, fork join, services, key value, transactions, all of these kind of things very important in the financial world, as we tried to allude to a little bit earlier on. And then the kind of high-level applications that they have, payments, accounts, credits, clients, securities, all of these kind of things. And then building front-end APIs using a variety of different tools and languages. Okay, so this gentleman is the CEO. And essentially he's saying there that they want to bring new products and services to the market very quickly. And they want to be able to have a lot of reliability, availability, scale, and these kind of things. I won't read it, okay, because we're kind of pressed for time, and I need to wrap up fairly soon. But lots of important issues that they're trying to address in that statement. If you're familiar with supercomputers and you keep an eye on these things, then the system that they're building is comparable to this, not quite on the scale of this. I mean, this thing is massive, it's huge. And in terms of the processing that it can do, it's phenomenal. So not reaching those kind of levels, but this is the kind of high-level architecture, high-level model, if you like, that they are using in their own system. So very quickly then, look at the challenges that they had, 5 sort of main challenges. So they've got a terabyte plus per server, okay? So that's a reasonable level of memory, keeping a fair bit cached. Because Ignite is a Java-based system, as you know, garbage collection can be an issue, and particularly if you've got a large amount of memory, the system might stop, stop the world type garbage collection, terrible. You don't want those kind of situations. So Ignite has its own off-heap memory management system, which they've written, and that can be as large as you want. Terabytes and terabytes and terabytes. You can add literally, and it will manage that for you. So you take away a lot of the responsibility from Java. Make the on-heap as small as possible, and then keep the off-heap as large as possible. So let Ignite manage that for you. And again, sort of a high-level picture in terms of some of the things that it can do: automatic defragmentation, off-heap removes notable garbage collection pauses. Okay, the disk itself. Okay, so remember we talked about this persistence and durability. So on the disk, all of the data are stored. Okay, and then in the cache itself, part of the data are stored. So you're seeing like a subset of the data stored. But Ignite again transparently manages all this for you. Fully transactional, predictable memory consumption. Okay, this is, again, because Ignite can do the off-heap memory management for you. Almost finished. Okay, so just a couple more slides. So one of the key requirements then is they've got very, very stringent SLAs. So in the event of a catastrophic failure of some kind, the thing must be brought up as quickly as possible. And so one of the requirements is under 5 minutes. I mean, that's pretty strict. Remember the size of this bank, the fact that they span huge number of branches and time zones and all sorts of issues related to that. So you can kind of see at scale the kind of problems that they will have. And they can't wait for disk loading, okay? So need to operate from disk. So this is where that durability and persistence capability we talked about just a few moments ago really comes in, because these snapshots and other capabilities allow them to bring the system up very, very fast. If you're familiar with logging and write-ahead logs, okay, so with relational database systems, this is one of the capabilities that they use. So when updates are done, they're not done in place. That's expensive. It's just written to a log. At some point, the updates in that log are actually applied. Okay, the log is shrunk, and then that's the way it's done. So this is standard, approach to dealing with those issues. Third issue: thousands of data types. Okay, and you can appreciate that as a large bank and a financial institution, there's a lot of stuff that they need to be able to store, and many different models that they have to create, and versioning of these as well, perhaps for historical reasons or legal reasons or other reasons as well. Fast replication and partitioning, distributed SQL joins. I think be careful with distributed SQL joins. As you know, I mean, if you run a query badly or you've written it very badly, you can bring the cluster to its knees. Ignite doesn't prevent you from doing that. It's just you need to think carefully about how you do these. I mean, it's got some foreknowledge in terms of what you might be trying to do, but it won't stop you from doing this. Okay, so again, careful design in terms of your architecture, how you're doing these joins. Co-location is a good solution. Okay, being able to locate data together on particular nodes so that you don't have to search the entire cluster for data. That's again useful thing to keep in mind. We talked a little bit about this, and because this is a Java-based product, JCash, if you're familiar with that, transactions, compute, SQL, logical caches, and we talked about the fact that this is a distributed partitioned hash map already. Okay, so almost there. This is pretty much covered in everything we've talked about. I think the main thing here is JDBC support, ODBC support. Okay, these are standard in industry standard. Standard SQL 99 API, okay, so that might cause some issues for you if you're looking for something a little bit beyond that. That may come in due course. And then access from a variety of different languages. If you're using Java, .NET, C++, those are extremely well supported. They are almost interchangeable. And I mean, obviously, there are some differences between languages and frameworks. So you need to, again, think about this carefully. But Ignite uses an internal binary format that you can use to read and write data, regardless of what language you're working with, whether it's Java or .NET or C++. If you search on dzone, I wrote an article not so long ago, a month or two ago, about how we could do this. Very simple example showing you how to access the cluster using Java and .NET, how to read and write objects. Very straightforward and simple example, but it works. Okay. Okay, so we're almost at the end there. So backups and again, data restore. It's important to be able to be confident in that if we lose our cluster for some reason, that we can restore the data back as well. And we keep the backups as well for historical reasons as well, for legal reasons, for compliance reasons, and so on. And you can actually restore data back to a cluster that's of a different size. That's entirely possible too. You may find that that's useful in some situations. Full incremental backups, okay, we've talked about this already. And last point, disaster recovery. Okay, so this is one of these kind of enterprise features which they're using specifically from GridGain. So it's not part of the Apache distribution. But again, what they're trying to do is that they've got some particular requirements in terms of minimizing the downtime. And their architecture kind of looks a little bit like this. I mean, it's not precisely, as you can see, this is a kind of a global picture. So it's active-active, active-passive. And you can design it in a way that in the event an asteroid hits Russia, for example, you knock out your data center there, that if it's globally distributed, it is working in other parts of the world as well. And you've got your data backed up in other locations. Quite a useful feature. So they've got this capability as well that they're using. Okay, I apologize. I'm a little bit over. Okay, so sorry about that. So happy to take a couple of questions, or we can break for coffee, and you can grab me outside as well, so no problem. So maybe one or two questions we can take. Thank you.
Thanks, Akmal.
Yes.
Very interesting question.
Okay, thank you.
The question that I have is with respect to being a very old bank,
Yes.
servicing a large population in Russia.
Yes.
You might have a lot of legacy applications connecting to various product classes. So what kind of challenges you had with respect to mapping up to those legacy systems and trying to layer up on some of the capabilities that Ignite Apache is bringing along?
Okay, so the question is really asking about legacy applications, which is kind of an interesting thing, because historically, if you've got lots of things that you've built over time, there is value in these applications and systems, and you're not going to throw these away. So I think with this type of architecture, what they've done is they've written wrappers around it. That's the way that they've approached it. Many years ago, and I apologize, I'm just going off a slight tangent, but just to illustrate the point. So I'm old enough that I remember the Y2K problem, okay? So I worked for Logica, and we worked for a client here in London, in Euston, and this customer had over 500 applications that needed to be tested for this compliance issue. And it was very interesting because some of these applications, just the binary existed. There was no source code, no documentation. People knew how it worked, okay? It would take inputs and outputs. It was an totally black box. How do you deal with these kind of situations? So in the extreme case, there's not much you can do, really. So the way to do it is to kind of wrap it, have standard APIs that you can use to call this, and then you have the ability over time to swap that system out if you want to, without having to worry about whether it's legacy code or not anymore. You can rewrite it in time. That's entirely possible. So I think it's a tough question to answer, but a very good question that you asked, because we are not always in the fortunate situation that we can start a greenfield from scratch. There's always business value in things that we've written before. And I think what we have to do is to find good ways to be able to manage those applications, wrap them, take the value that we can from them. And Ignite will, as a cluster computing architecture, it will support you in terms of giving you the performance and scale for that, but it will be up to you to write those legacy kind of wrappers, if you like. I think that's how they address the challenge. Okay. Any other questions? Okay, yes.
I've got two, but hopefully they're very short.
Yes.
The first one is, it's a distributed Java process. Does it depend on Zookeeper? And if so, how does that affect reliability?
Okay.
And the second question, you can answer them in any order. The second question was, we've talked about it being large and fast.
Yes.
Is it performant as a data warehouse, or is it not good for that?
Okay. So the first question was that, does it depend on Zookeeper? No. It's a peer-to-peer system, so you don't and Zookeeper is terrible. Okay, I shouldn't say that. It's an Apache project as well. But it can be terrible. If you've set it up incorrectly, I think it can cause you problems. So the fortunate thing is Ignite is just a peer-to-peer cluster. There is no master-slave also. You can have data on a kind of like a master data on one particular node and have backups, a primary and sort of secondaries. You can do it that way, but there is no kind of special node that is required. Once you fire these nodes up, they discover each other. Depending, you can use multicast, static IPs, Kubernetes even, or something like that, and it will these nodes will find each other. They'll just form the cluster. And I think in terms of your second question, so please repeat that again.
Does it work as a data warehouse?
Okay, so a data warehouse. I think at the moment, it's really designed for a lot of cluster computing. Data warehouse kind of tends to have different characteristics and applications. I think certainly it could be used to enhance a data warehouse. So for example, if you want a bit of scale and speed, you can certainly read a lot of SQL stuff into Ignite. I'm just working on a couple of demos, just to quickly mention this, where I've taken some SQL data. I don't know if you're familiar with SQL Line. It's a great kind of command line tool that you can use, and the same thing would apply to MySQL, Postgres, or any other relational system, or any data warehouse that uses JDBC, ODBC sort of connectors. You can read that data into Ignite. It will cache that data, and then you can just run it at memory speeds, and that really improves the performance. So I would see it more as a complementary technology, something that can enhance what your existing data warehouse already has. And again, it goes back to this whole philosophy of no rip and replace. If you're using something, but you find some problems in terms of performance, this could be useful in terms of reading data from there, being able to cache it. And remember that the way this works, it can do it under transactional control, okay? So you can update the data in the cache, you can write it back out to your data warehouse, which is your kind of single source of truth, if you like. So if your cluster goes down, no problem, your single source of truth is still okay, so. Okay, if you want to reach me, so it's just firstname.lastname@gridgain.com. I'd be very happy to answer your queries, any issues and concerns. Again, my apologies, I'm a little bit over. So grab me outside, and if there's anything else I can help with.
Thank you, Akmal.
All right, thank you.
Thank you.